Hello friends, today we are going to learn trigonometry. Trigonometry is one of the most important part of geometry, and I have found that many students find it difficult to understand trigonometry and to solve problems based upon trigonometry. So to start with, let us understand the meaning of the word trigonometry. Trigonometry is derived from three Greek words: tri, gon, and metron, where tri means three, gon means sides, and metron means measuring these sides, or you can simply say measurement. Okay, so as the name itself suggests, trigonometry is used to find out unknown lengths, heights and distances by comparing different scenarios with respect to three-sided figure. Okay, so as we all know, in geometry a three-sided figure is called as triangle. So trigonometry basically compares different scenarios with a triangle. To be more specific, it is the right angle triangle. Okay, so before learning trigonometry, it is important for us to understand why do we need to learn it, or why do we need to learn trigonometry, and what are its applications. So the heights of the tall mountains, the distance between sun and earth, the distance between moon and earth. Yes, the answer to all this question is trigonometry. We have been able to do all this only by using trigonometry and by using trigonometric ratios. So to start with, let us first revise the Pythagoras theorem, which we have already studied in our previous classes. So the Pythagoras theorem states that in a right angle triangle which has three sides, side AB, let us consider this triangle which has three sides, side AB, side BC and side AC. Okay, side AB as side 1, side BC as side 2 and side AC as hypotenuse. So the Pythagoras theorem states that side 1 square plus side 2 square is equal to hypotenuse square. Okay, let's take an example. Let side 1 be 3 and side 2 be 4. So side 1 square, that is 3 square, plus side 2 square, that is 4 square, is equal to hypotenuse square. Okay, so what is the square of 3? 9. Square of 4? 16, which is equal to 25. Okay, so hypotenuse will be root of 25, isn't it? So hypotenuse will be 5. Understood the Pythagoras theorem? Okay, now let's move further by learning the different trigonometric ratios, angle A and angle C, and we have considered angle C as theta. So measure of angle A will be 90 degree minus theta. Okay, why have we considered A as 90 degree minus theta? Because the sum of angles of a triangle is equal to 180 degree, and since B is equal to 90 degree, since B is equal to 90 degree, and we have considered angle C as theta. So angle A will be 90 degree minus theta, because the sum of angle A plus angle C should be 90 degree, and since angle C is theta, so A will be 90 degree minus theta. Okay, now let's move on towards learning trigonometric ratios. So trigonometric ratios are sine, cos and tan. Okay, so we'll try to find out sine ratio, cos ratio and tan ratio for this triangle ABC. So in this triangle ABC we have two unknown angles, angle A and angle C. So let us consider angle C as theta. So we will be finding all the trigonometric ratios with respect to theta. So let us rename the sides of this triangle ABC. So with respect to theta, side AB will be the opposite side, or we also call it as perpendicular side. Okay. Similarly, with respect to theta, side BC will be adjacent side, or we also call it as base side. Okay, and side AC will be hypotenuse. Okay, so let us find out the trigonometric ratios. So sine theta is given as opposite side upon hypotenuse. So with respect to theta, the opposite side or the perpendicular side is side AB and the hypotenuse is side AC. Okay. Similarly, for cos theta is given as adjacent side upon hypotenuse. So with respect to theta, the adjacent side or the base side is side BC and hypotenuse is side AC. Now let's find out tan theta. Tan theta is given by opposite side upon adjacent side. So with respect to theta, the opposite side is side AB and the adjacent side is side BC. So AB upon BC. So students, have you understood the basic trigonometric ratios? Well, have you noticed tan theta is opposite side upon adjacent side. So tan theta is basically the ratio of sine theta upon cos theta. Why? Because sine theta is opposite side upon hypotenuse and cos theta is adjacent side upon hypotenuse. Opposite side upon hypotenuse into hypotenuse upon adjacent side. This is the reciprocal of this thing. Okay, so hypotenuse get cancelled, so what remains is opposite side upon adjacent side. So understood? Students, let us confirm our understanding by taking an example. So the question is, if sine theta is equal to 3 upon 5, we have to find cos theta and tan theta. So let's draw a figure, a right angle triangle. Let's call it XYZ. Angle Y 90 degree. Okay, angle Z is theta. Okay, so here sine theta is given as 3 by 5. We know sine theta is opposite upon hypotenuse, that is 3 by 5. So opposite side to angle theta is side XY, which will be 3, and hypotenuse is XZ, which will be 5. Okay, and the length of YZ we don't know, it is unknown. So we'll first find the measure of side YZ by using Pythagoras theorem. Okay, so let's use the Pythagoras theorem, which states that xy square plus yz square is equal to xz square. Okay, so here we have to find yz square, which is nothing but xz square minus xy square. Xz square is nothing but 5 square, and xy square is square of 3. So it is 25 minus 9, which will be equal to 16. So yz will be root 16 is equal to 4. So we have found the measure of side yz, which is 4. Okay, now let's write all the trigonometric ratios for triangle xyz. So we have the sin theta. So cos theta is given by adjacent side upon hypotenuse. This is the adjacent side, this is the opposite side, this is the hypotenuse. Okay, so adjacent side yz. Okay, so 4 upon hypotenuse is side xz, which is 5. Similarly, tan theta will be opposite side upon adjacent side. Opposite side is side xy, which is 3, and adjacent side is side yz, which is 4. Okay, so in this way we have found cos theta and tan theta for given sin theta. Okay, now we'll be learning the derived trigonometric ratios. So derived ratios, which are sec, cosec and cot. So let us find out these trigonometric ratios with respect to theta. So sec theta is given as hypotenuse upon adjacent side or the base. Okay, so here hypotenuse is side AC. We are looking at this triangle ABC. Okay, and adjacent side is side BC. Okay, similarly cosec theta is given as hypotenuse upon opposite side or the perpendicular side. Okay, so hypotenuse is side AC and opposite side is side AB. Okay, and cot theta is given as adjacent side upon opposite side. Okay, so the adjacent side with respect to theta is side BC, and the opposite side with respect to theta is side AB. Okay, so in this way we have learned the 6 trigonometric ratios. Cos theta, if you remember, is given as adjacent side upon hypotenuse, and sec theta is exactly the opposite of it, the reciprocal of it, which is hypotenuse upon adjacent, right? Similarly, cosec theta is the inverse of sin theta. Sin theta is given as opposite side upon hypotenuse. You can see that cosec theta is given as hypotenuse upon opposite side. Similarly, cot theta is inverse of tan theta. Tan theta is given as, if you remember, opposite side or the perpendicular side upon adjacent side or the base side. Okay, and you might have seen cot theta as adjacent upon opposite side. Okay, so understood why do we call this as derived ratios of the basic trigonometric ratios? Fine, is equal to 1 by 2. We have to find all the other trigonometric ratios. Okay, so let us first draw the figure. Right angle triangle. let's name it ABC. Okay, angle B is 90 degree. Let us consider angle C as, no, let us consider angle A as theta. Okay, so what will be the change? With respect to angle theta, side BC will be the opposite side or the perpendicular side, and side AB will be the adjacent side or the base side. Okay, side AC will be the hypotenuse. Okay, any doubt? Okay, fine. So here we have the tan theta, which is given as opposite side upon adjacent side, which is 1 by 2. So here the opposite side, that is side BC, is 1, and adjacent side, that is side AB, is 2. We have to find side AC. Okay, so how do we find side AC? By using the Pythagoras theorem. Okay, so AB square plus BC square is equal to AC square. We very well know that, the Pythagoras theorem. Okay, so what is AB? 2. So 2 square plus what is BC, that is 1. So 1 square is equal to AC square. Okay, so square of 2 is 4, square of 1 is 1, which is equal to 5. Okay, so AC will be is equal to root 5. Okay, so now let us write all the trigonometric ratios for triangle ABC. Okay, so first of all, sin theta, which is opposite side upon hypotenuse or the perpendicular side upon hypotenuse. So the opposite side is side BC, hypotenuse is side AC, which is BC is 1 and AC is root 5. So sin theta will be 1 upon root 5. Okay, similarly cos theta, which is given as adjacent side upon hypotenuse. Here the adjacent side is side AB and hypotenuse is side AC. So what is the measure of adjacent side? 2, and hypotenuse is root 5. Okay, so cos theta will be 2 upon root 5. Okay, tan theta, we already have tan theta. So sec theta is given as hypotenuse upon adjacent side. Here the hypotenuse is side AC and the adjacent side is side BC, sorry, side AB. Very good, if you have understood the mistake. Okay, side AC is root 5 and side AB is 2. So sec theta is nothing but root 5 by 2. Now cosec theta. Cosec theta is given as hypotenuse upon the opposite side or the perpendicular side. Here the hypotenuse is side AC and opposite side is side BC. Measure of side AC is root 5. Measure of side BC is 1, which is equal to root 5. Okay, now the last cot theta. Cot theta is given as adjacent side upon opposite side. So the adjacent side to theta is side AB, which is 2. Okay, and the opposite side is BC. Adjacent side is 2, opposite side is 1, so it is 2. So students, if you have noticed, cosec theta is root 5, which is the reciprocal of sin theta. Sin theta is 1 by root 5 and cosec theta is root 5 by 1. Okay, so that is the reciprocal of sin theta. Okay, cot theta is the reciprocal of tan theta. Here cot theta is 2 upon 1, whereas tan theta is 1 by 2. Similarly, sec theta is the reciprocal of cos theta. Here sec theta is root 5 upon 2, whereas cos theta was 2 upon root 5. So from here what we can say is cosec theta is equal to 1 upon sin theta. Therefore cosec theta into sin theta is equal to 1. Similarly, sec theta is equal to 1 upon cos theta. Therefore sec theta into cos theta is equal to 1. Similarly, cot theta is equal to 1 upon tan theta. So therefore we can say that cot theta into tan theta is equal to 1. Okay, so I hope that you have understood the basic trigonometric ratios, derived ratios, all the 6 ratios, and how do we find out measure of unknown side and find different trigonometric ratios. So if you like this video, do not forget to like, subscribe and share this video. And okay, the next topic will be trigonometric identities. So if you have any doubts or any queries regarding this, so I hope that you have understood whatever we have studied today. So if you like the video, please do not forget to like, share and subscribe. And if you are having any doubt or queries, please line up your doubts in the comment box. I will be answering to all your doubts in the next video. Till then, stay safe, stay home. Thank you and bye-bye.